Chapter: Classification of Elements and Mendeleev's Periodic Table. Throughout history, various attempts have been made to classify elements systematically. In this chapter, we will explore the concept of classification, along with the triad, octaves, and Mendeleev's periodic table. We will also discuss the merits and demerits of these concepts. 1. Classification of elements. Elements are classified based on their atomic structure, chemical properties, and physical properties. The goal is to arrange elements in a way that highlights their similarities and trends. 2. Triads. In 1817, Johann Wolfgang Dobereiner proposed the concept of triads. According to this concept, elements with similar chemical properties could be grouped in sets of 3. The middle element of each triad had properties that were an average of the other 2. For example, Dobereiner identified the triad of chlorine, Cl, bromine, Br, and iodine, I, which showed similar chemical behaviors. Merits of triads. Triads provided an early attempt at classification based on chemical properties. They helped in identifying patterns among elements with similar properties. Demerits of triads. The concept of triads had limited applicability as it could only accommodate a few elements. It did not provide a comprehensive classification system for all known elements. 3. Octaves. In 1864, John Newlands proposed the concept of octaves. He noticed that when elements were arranged in order of increasing atomic mass, every eighth element exhibited similar properties to the first. This led to the comparison of elements with musical octaves. Merits of octaves. Octaves provided a way to organize a larger number of elements compared to triads. They highlighted the periodic repetition of properties. Demerits of octaves. Octaves suffered from inconsistencies when applied to a wider range of elements. It failed to accommodate the discovery of new elements that did not fit into the pattern. 4. Mendeleev's periodic table. Dmitry Mendeleev, a Russian chemist, is credited with the development of the modern periodic table. In 1869, he published his version of the periodic table, arranging elements based on their atomic mass and properties. Mendeleev left gaps for undiscovered elements and predicted their properties accurately. Merits of Mendeleev's periodic table. Mendeleev's periodic table was a comprehensive and systematic classification of elements. It successfully predicted the existence and properties of undiscovered elements. The periodic table allowed for the identification of trends and patterns among elements. Demerits of Mendeleev's periodic table. Anomalies in atomic mass order. One of the demerits of Mendeleev's table was the arrangement of elements solely based on their atomic mass. In a few instances, certain elements were placed out of order to maintain similar properties within a group. This resulted in some irregularities, such as the inversion of tellurium, Te, and iodine, I, due to their atomic masses. This inconsistency posed a challenge in maintaining a strict ordering of elements based on atomic mass. Incomplete understanding of atomic structure. During Mendeleev's time, the understanding of atomic structure was incomplete. The concept of atomic number, which is now used to determine the order of elements, was not discovered yet. As a result, The periodic table had some inaccuracies in terms of element placement and grouping. Without the knowledge of atomic number, some elements were misplaced based on their atomic masses, leading to deviations from the periodic trends. Placement of isotopes. Mendeleev's table did not account for isotopes, which are atoms of the same element with different atomic masses. Isotopes have identical chemical properties but differ in their atomic masses. Since Mendeleev classified elements based on atomic mass, isotopes of elements could not be distinguished within the table. This limitation prevented the accurate representation of all variations of an element. The underlying cause of periodicity, which is the arrangement of electrons in atomic orbitals and energy levels, was not known at that time. This limitation hindered a deep understanding of the periodic trends and patterns observed in the table. Rare earth elements. The placement of rare earth elements within Mendeleev's periodic table was a challenge. These elements possess similar properties and were difficult to differentiate and place accurately in the table due to their complex electron configurations. Despite these demerits, Mendeleev's periodic table was a groundbreaking achievement and laid the foundation for the development of the modern periodic table. It provided a framework for organizing elements based on their properties and atomic masses. Conclusion. The classification of elements has evolved over time, starting with the triads and octaves concepts, leading to the development of Mendeleev's periodic table. While triads and octaves had limitations, Mendeleev's periodic table provided a comprehensive classification system. It served as the foundation for the modern periodic table, which is organized based on atomic number and displays periodicity and properties. The periodic table continues to be a crucial tool in understanding and studying the elements and their relationships in chemistry.